Welcome to another episode of Bite Sized Maths, where we will be covering maths topics in small and easy to understand videos. Today's topic will be matrix multiplication, specifically speaking, scalar multiplication, and matrix to matrix multiplication. Scalar and matrix. So let's get started. So first off, we will be starting with scalar multiplication. Scalar, scalar multiplication. So, what is scalar multiplication? Let's take a variable. Let's say d. This d can be any number. Any number, real or complex. Let A be a matrix whose general term can be written as Aij m cross n. So A is a matrix of order m cross n and its general term is written as Aij. So if we do if we do scalar multiplication of d with A, then the end result will be d times Aij for all the terms in the matrix of order m cross n. And this matrix is known as a scalar multiple of A of A. So now let's continue with some properties of scalar multiplication. So first property of scalar multiplication property number 1, A times B into A equals AB into A equals B into AA. So this is property number 1. Property number 2 is A plus B times A equals plus BA. Now keep in mind all the capital letters here denote matrices and all the small letters are denoting any number, real or complex. Now property number 3, A times matrix A plus matrix B equal to A times A plus A times B. Fourth, A into null matrix M cross N, I'm writing it large so that it doesn't cause confusion, will always lead back to null matrix M cross N. And fifth property, 0 into A M cross N will equal to null matrix of order M cross N. So these are all the properties of scalar multiplication. So these properties are really easy to prove. So I hope I do not have to provide proof of it, but if you want, we can do that in another video. So let's scroll down a bit more and start with matrix multiplication. Matrix multiplication. So the very first requirement of two matrices to be multiplied together is if the number of columns in the first matrix, so this is an if and only if condition, so if number of columns in first matrix equals number of rows in second matrix. Now because of this condition, it's not necessary that if A into B, matrix A into matrix B is possible, does not necessarily imply that B cross A is also possible. Does not imply is possible because of this condition. So keep that in mind when we are doing matrix multiplication, because order in which you multiply the matrices is very, very important whenever we are multiplying matrices together. In fact, if A into B is possible and B into A is also possible, let's say if a case exists where both of these multiplications are possible, this one and this one, then I will show you an example where these two multiplications are possible, but they give entirely different results. So let's keep going and see how the matrices are multiplied. So let's write our three matrices in the general terms. A equals Aij M cross N. B we write as B Ij N cross Q. and our matrix C, the resultant matrix, as Cij M cross Q. You see this? The resultant matrix of multiplying A with matrix B results in a matrix whose order is completely different from any of its parents. So A was M cross N, B was N cross Q, and C is M cross Q. So now, if we write how these terms gets carried out, so Cij is equal to summation k equals 1 to n aik and b k q. Sorry. B K J. Now this formula doesn't teach us anything, right? This formula is just a formula, doesn't teach us how to do it. So let's see with an example. So let's scroll down a bit and let's see it with an example. So let's take an example of 2, 7, 4, 5, 9, 8. This is our matrix A. Let's say we have a matrix B of order which is a column matrix 10, 4, 9. So let's first check if the multiplication is possible. So order over here, 2 rows, 3 columns, 2 by 3. Order here, 3 rows, 1 column. So the number of columns in the first equals the number of rows in the second. So multiplication in this case is absolutely possible. So now let's multiply them. So our resultant matrix C will be of order 2 by 1. Now you will soon see why I'm writing such a large matrix. So 2 into 10. 2 into 10, and since this was a summation, plus 7 into 4 plus 7 times 4 plus 4 into 9. Now second, 5 into 10 plus 9 into 4 plus 8 into 9. This is a 2 by 1 matrix. So this will give us the end result of 84 and 158. So our C matrix turns out like this, 2 cross 1. So this is how you do a matrix multiplication. Now, as I said, I will show you an example where A times B is possible and B times A is also possible, but they are not necessarily the same. So let's see an example. So in this case, our matrix A is 2, 5, 1, 8. Our matrix B is 1, 4, 3, and 7. So now we will take these same matrices 1, 4, 3, 7 and 2, 5, 1, 8 and multiply them in in completely different order. So let's see. 2 into 1 will give us 2 plus 5 into 3, 15. 2 into 4, 8 plus 5 into 7, that will be 35. 1 into 1 will give us 1 plus 8 into 3, 24. And 1 into 4 will be 4 plus 8 into 7, 49, 56. This will give us a resultant 2 by 2 matrix of 17, 43, 25, and 60. Now let's compare it with the multiplication result when we multiply it the other way around. Let's go. So 1 into 2, 2 plus 4 into 1, 4. 1 into 5 will be 5 again, plus 4 into 8, 32. 3 into 2 will be 6 plus 7 into 1 will be 7 and 3 into 5 will be 15 plus 7 into 8 will be again 56. Now the resultant matrix is 6, 37, 13 and 71. So this is our resultant matrix. Now as you can see, these two matrices are not at all equal because the first term is different, the second term is different, like every term is different. So even though AB was possible and BA was also possible, these two were not equal. So now let's cover up the properties of matrix multiplication real quick. So the first property is known as associative property. Properties of matrix multiplication. Property number 1, associative property. So whenever matrix multiplication is possible in such a way that three matrices can be multiplied in this order A, B, C, then A into the resultant of BC is same as A into B, the resultant of AB into C. This is the first associative property. Property number 2, left distributive property. Left distributive. So if we are multiplying A into the resultant sum of B plus C, this will give us an equivalent of AB plus AC. So this is the left distributive, and similarly there is the right distributive. Both of these are under distributive properties. So if we are multiplying the sum of A and B with C, this will be equivalent of AC plus BC, the right distributive. So, and as we previously discussed in our very first video, the identity matrix if you remember, property number 3, for every square matrix A, IA equals AI equals A. So this is the multiplicative identity for matrices. I is identity matrix. And this will be all for today, as I do not want to stretch the video further. So let's conclude our discussion about matrices at this point. In the next video, you will see some examples of matrix multiplication. And till then, like and share if you found the video useful, and subscribe if you want to keep seeing videos on such topics. Until then, sayonara.